I hope I hope that you all are comfortable and ready for the next session. So today we will be going deeper into, or we will be approaching a bit of mathematics, mathematical calculations, certain formulae basing on our data analysis. So during the last two sessions, we are through with how can we collect our data. So after the collecting our data, we have classified our data and we have tried to tabulate the data. So after the tabulation of the data, we have to make a certain analysis and speak about how the data is behaving or whether the purpose for which we have collected the data is suiting to that or not. For that purpose, we have to proceed with analysis. So while analyzing, we will be trying, first of all, we will try to describe our entire table by using a single terminology or a single, we will represent the entire table with a single number or a one one specific measure which will represent our entire table of data. We will try to understand how can we do that by using our data. So that is what is called as your measures of central tendency. Okay, so this is here we go. Basically, when we are, all of us, we are into our MBAs, we are supposed to deal with certain business problems, certain economic problems, and certain management problem. And if we are into the marketing, then we have to provide certain, we have to do certain research and so on and so forth. And in doing so, we will be dealing with a large amount or huge volume of data which we always collect through our surveys or through our questionnaires. So this these may be our financial records, marketing studies, and operational activities of a business. So to analyze each individual data is complex and time consuming. To simplify that information, in statistics, the statisticians use a measure called as measure of central tendency, which represents your entire or huge volume of data can be described by using a single number. Or you may say your measure of central tendency, which provide a single representative value which summarizes the entire data set. So these measures help in identifying a typical average value around which the data observations are concentrated. So making it easier to interpret trends and patterns. In many occasions, it happens that during the throughout the year, you will be recording the sales of a specific commodity in your district, and at the end of the year, you will be in a position to describe that during this particular year, our average, you may say, average sale of this particular commodity is this much, or during the previous so many years we are having this trend of our commodity in the market. So these measures basically help in data summarizations, comparing the several districts, that means a specific commodity, the sale of it in Odisha, sale of it in Calcutta, sell of it, sorry, West Bengal, sell of it in Maharashtra, and so on and so forth. So, basing on that, you will be in a position to decide about wherein the demand of your product is maximum or is increasing or is decreasing, and if you will be in a position to decide that or make a decision on that particular thing, then you will be in a position to decide about how can I deal with my product so that it can be popularized throughout the country. So the measures of central tendency in that aspect form the foundation of statistical analysis and decision making in business and in management. So basically we are having several measures of central tendency, but most frequently used are these three, that is mean, median and mode. And if your curve is like this, we call it as a bell-shaped curve. Then at the top of it, your mean, median, mode, all the three things are equal. So, definition of a measure of central tendency. There are several definitions, but precisely we may say that your measure of central tendency is a statistical measure which basically being identifying the centermost or central or tip value of your data set. It basically represents the value around which the observations in a data set tend to cluster. So, in other words, it is a single representative which summarizes the entire set of data. And most commonly used measures of central tendency are basically mean, otherwise it is called as your arithmetic mean, median, mode. And in addition to these three, there are several other measures of central tendency. They are geometric mean, harmonic mean, weighted arithmetic mean, and quantiles, which are having the specific, uh, or you may say these last four measures, they are basically being used in specific cases, and we will be describing or we will be indicating wherein these four are basically being used. So these measures basically help to simplify your large data sets, and after measuring this you will be in a position to, or these measures they support interpretation, comparison and decision making in your business and management analysis. So core measures are your mean, median and mode. Each describe a typical values from different perspectives. It may be average value is your mean, median is the middlemost value in the series, and most frequently occurring value is your mode. Okay, that means if you are having a set of scores of the students, then the mean if you will be adding all the scores divided by the number of students, that will be the mean, which is called as your average. And median, if you will be having a 10 students, then to calculate the median of your this thing you have to sort the values and find out the middlemost value. And similar is the case with mode, in wherein suppose say how many students have scored 99. If the number of students scored 99 amongst all, then the, is the most, then we call is that mode value. So why it matters? These help your decision makers to quickly interpret behavior, usefulness in business analytics and policy formulation. So why should we study our measures of central tendency, or what is the basic objective behind having such a measure in your quantitative techniques or in statistics? So main objectives are they provide a single value which will be representing the entire data set. That means to summarize your data, you may require to may calculate the measure of central tendency. And if you are having a huge volume of data, you can describe that huge volume by using a single number, by measuring the central tendency. So it will be simplifying your complex data. And if you are having several groups, several regions, several time periods, then while studying a specific Suppose say impact of a specific scheme of government of India, it will be applicable to several categories of the people. We can group them as per regions, as per age, or so on and so forth. So, in which age group or in which region that particular scheme is more performing very good or better, that to study that also you will be requiring to calculate the measure of central tendency of the data collected, and it assists managers and researchers in making informed decisions based on the data and to provide, and this is the, you may say, foundation for other statistical techniques in the further lessons of this particular course or this particular paper. You will find that your measures of central tendency need to be calculated at each and every, whether it is dispersion or whether it is correlation analysis or whether it is regression analysis in case of your statistical techniques. And in addition to that, if you will be testing the hypothesis, whenever you will be deciding about the hypothesis, and then also the mean or average or median or the mode, these are the things which are to be calculated first. So the measures of central tendency is considered as the foundation for all statistical techniques to cover. So main types of the measures of central tendency at the very outset. Let us decide about that. Measures of central tendency are statistical measures that represent the central or typical value of a data set. They will help you, as we discussed, they help in summarizing the large volume of the data into a single representative value. And main types, number one is your arithmetic mean. As I am sure that every one of you are aware of it, that the arithmetic mean is calculated as the sum of all average observations divided by the number of observations. Most widely used, this is the most widely used measure, and it is mean is equal to summation. That's a big sigma. We read it as summation x by n, wherein your x is the number. That means what is the value of that specific observation. If it is the scores of the students that you are taking, then x is the score of a student. And if you are taking it as average monthly salary of a personality, then x represents the monthly salary of a specific person, individual. And similarly, if you are considering the sales, monthly sales, then it is the sales on that particular day. So, example may be average monthly sales of a company. And number two, it is a variation in your arithmetic mean. We call it as weighted arithmetic mean. This is basically being used whenever in universities each and every subject carries a certain number of credit points, and you will be scoring a certain marks. So based on your marks and the credit points of that particular credits, how many credits that particular paper carries your entire syllabus. That credit is your weighting width, and the score that you will be scoring is X. That means suppose say this particular paper, that quantitative methods for managers, it is having 3 credits in your syllabus or in your curriculum, and your score is 40, then it, while calculating your grade points, this particular paper's weight is say 3 into the score of yours, that carries that summation wx by summation w. So this particular average or this particular Weighted arithmetic mean is being used while calculating the grade point averages or your index numbers, price index, etc. So used when different observations are different importance. Okay, so in any university curriculum, depending upon your curriculum, if it is an MBA, then the more weightage is given to your finance paper, more weightage will be given to your law paper, more weightage to given to your all other management papers, but less weightage to your IT paper and so on and so forth. So that weight or that credits that each and every paper is being defined, is carries in your curricula, is while calculating grade point that need to be taken into consideration along with your score. So while doing so, it is called as the weight associated with your score. So weighted arithmetic mean. Then one is your median. So the middle value when data are arranged in order. So the median requires that the data available should be arranged in ascending or descending in a specific order. It divides the data set into two equal parts, suitable when data contains extreme values, the median income of households. And mode is the value that occurs most frequently in a data set. So it is useful in market research and consumer preference analysis, wherein it is being used as most popular clothing site. While okay, and one more is your geometric mean. It is used for growth rates and percentage changes. Population growth rate, investment returns, this is the, and the calculation of each one, we will be doing it along with the formula associated with it. The next one is harmonic mean. It is used for averaging rates such as speed or price per unit. So average speed over equal distances. And one more is your quantiles. It is positional averages. The divide data, that means in a specific data set, these averages will be at a specific point. So this divides your entire data set into several equal parts. So these quantiles may be quartiles, which will be dividing your entire series into four parts, deciles, which will be dividing your entire series into 10 parts, and percentiles into 100 parts. So these help understand the position of values within the data set. Okay, that is the typical value and this is the positional value. So your positional averages, quantiles are your positional averages. So moving further and going along with the data, yesterday while studying our frequency distributions or while studying our classification, we were discussing about two things. One is our ungrouped data and one is our grouped data. Ungrouped, if we are simply scoring, collecting the data in a discrete mode. That means if individual data is being counted, then we call as ungrouped. And if there is no distinction, that means your data is in a specific range. If we are subdividing our data set on the basis of class intervals, then that is our grouped data. We are grouping the data. That means within a range of the numbers, a certain number of data are falling. So we will be calculating each and every this measure of central tendency for our ungrouped and for our grouped data. Okay. So arithmetic mean, it is also otherwise called as simply mean or average. is the most widely used and easily understood measure of central tendency, and in statistics, the term average generally refers to a value that represents the central or typical observation in a data set. So the arithmetic mean is obtained by adding all the observations in the data set and dividing the total by the number of observations. So it therefore represents the overall balance points of the data. That means while calculating the arithmetic mean, we are taking into consideration each and every observation in our data set. So symbolically, it is represented as x bar is equal to summation x by capital N, where your x bar represents the arithmetic mean and summation x is sum of all observations, and this N is the total number of observations. So suppose say you are taking into consideration the score of 100 students, then the average score of 100 students is the sum of the individual scores of 100 students divided by 100. Okay, that is what we have done here. So ungrouped data, which refers to data represented as individual observations without frequency distribution. Okay, so suppose say the daily sales of a product for 5 days we are taken into consideration. Monday 12 tons say, and Tuesday is 15, Wednesday 18, Thursday 20, and Friday 20, 25. Then the average sales in that specific week is this. That means we will be adding on 12 plus 15 plus 18 plus 20 plus 25. That is our summation x, and the total number of observations that we have taken is Monday, Tuesday, Wednesday, Thursday, and Friday, that is 5. And mean is equal to x bar is equal to, that summation is 90 divided by 5, that is 18. So arithmetic mean or average sales is 18 units. So this means that on an average the product sells 18 units per day. So on the basis of that, you may decide about how many units of production is required in your company. So when the data are arranged in class intervals with frequencies, we call it as grouped data, and the arithmetic mean for grouped data is calculated using midpoint of each class interval. Okay, so over here my class interval is 0 to 10, 10, 20, 20, 30, 30, 40, 40, 50. Okay, what will be the midpoint of it? The upper class limit minus lower class limit divided by 2. Okay, the midpoint of the class interval is upper class limit, that is 10, minus the lower class limit, that is 0, divided by 2. 10 minus 0 is 10, by 2 is 5. So next class is similar. It is 10 plus 0 by 2. It is 5. 20 plus 10 by 2 is 50. 30 plus 20 by 25, and so on in 2. Okay, the difference between the two is 10. The midpoint is 25. Okay, 25. So frequency, that means in that particular class interval we are having 3, 5, 7, 4, 1. Okay, so our formula says that summation of fx, that is frequency into midpoint of the class interval, divided by the sum of the observations, that is total number of observations, that is total frequency. Okay, So by midpoint, we mean the mid 0, 10. So mid will be 5. So over here is summation of f is your 3 plus 5 plus 7 plus 4 plus 1, that is 20. And summation of fx 3 into 5 is 15, 75, and so on. And sum of it is 450. So mean is equal to summation of fx by summation of f, that is 450 by 20 is equal to 22.5. So this represents the average value of the grouped data. So I'm sure you all are okay with whatever we have covered so far. So the mean that we have calculated, what are the basic mathematical properties that it possesses? Several important properties. One is that sum of deviation from mean is 0. That is, if you will be calculating the sum of the deviations, that is x minus x bar. Suppose say over here it is x is 12 minus x bar is 18, that is minus 6. Similarly, it is minus 3, it is 0. Minus 6, minus 3, 0. And it will be, sorry, it will be 2 and it will be 7. 7 plus 2 is 9, and this is minus 3 plus, sorry, minus 6 is minus 9. Minus 9 plus 9 is equal to 0. So this is algebraic sum of deviations of observations from the arithmetic mean is always 0. So x minus x bar, if you will be taking and you will be taking a sum of it, then always it will be resulting in 0. This means the positive and negative deviations cancel each other. One more is your least squares property. The sum of squares of deviations from the arithmetic mean is minimum compared to deviations from any other value. That means if you will be taking square of this and any other value, maybe other than your mean, then this sum will always be less than any other value. So you can take that. The third one is linear transformation. So if you will be adding a constant or subtracting a constant value from each and every observation of your series, the mean changes by the same constant. Okay. Whatever you will be adding to that value, your mean will be added to that. That means if you will be adding 5 to each of the observation, then your x bar will be x bar plus 5. And if each value is multiplied or divided by a constant, then accordingly your mean. Suppose say you will be multiplying each and every observation with a specific value, say a, then your sum will be a x bar. Okay. And one more is combined mean of several groups. Suppose say you are having several series of data, then in that case, the number of series, suppose say you are having a series of some of a series and another series, and if you will be calculating the average of both the combined, then in that case, the number of observations in one series into the mean plus number of the observations in the second series and the mean, and divided by the total, that is n1 plus n2. So why we basically prefer arithmetic mean? What are the basic advantages? It is very simple to understand and calculate. Calculation is very easy, just add up and divide it by the number of observations. And number two, it is very effective, or it is considered as a best average, as because it is based on all observations. Okay. It is, you may say, robust or rigid, and it is well defined. It has a definite formula and produces a unique result always. And it is suitable for further statistical analysis, like, or it is useful in advanced statistical techniques such as variance, standard deviation, correlation, regression, and all your large sample tests, small sample tests everywhere. And it is comparison between the data sets by using average is easier. So it facilitates comparison between different groups or periods. But each and every thing that is existing in this particular world are having several pros and several cons. Each and everything is having certain good features and certain features which will be troubling you or the majors. So number one over here is it is affected by the extreme values. If all the observations are something in between, but one of the observation is very high, in that case your arithmetic mean is not the suitable measure to make the study. And number two, it is not suitable for highly skewed data. That means many values. The mean may not represent a typical value in that case, as because many other values are smaller or larger. By skewed, I mean it will be having a long, we call it as tail of curve. So it cannot be used for qualitative data. If the data can be represented by using numerics, if you can count or if you can represent the data numerically, then only you can apply arithmetic mean, else it is not possible to use it. And it may not correspond to an actual observation. The calculated mean may not exist as an actual value in the data set, of course. So next is your weighted arithmetic mean is an average which different observations are assigned different weights according to their importance. Unlike the simple arithmetic mean, each value contributes to the average in proportion to its assigned weight. As we were specifying, suppose say you are having 4 subjects. In one subject your credit is 3, in another it is 4, in another it is 2, and in another it is 1. 4, 3, 2, 1. And in the credit points of 4, your score is 50. In that, in the other one it is 70, and so on and so forth. Then while calculating your grade point, your university will be calculating 50 into 4 plus 70 into 3 plus 30 into 90 plus 1 into 80. So, adding all this and divided by 4 plus 3 plus 2 plus 1. Okay, that is 10. Okay, and that is your grade point. So, while calculating grades, it is done like that. So, this is the average which is used while deciding about your CGPS and SGPS. So if this is the case that we were just speaking about, suppose say you are having a statistics paper having the credit point as credits as 4, economics 3, management 2, and accounting 1. So your weights are 4, 3, 2, 1. And while calculating your grade, it will be 4 into 80, that is 320, 210, 150, and 65. So adding up, it will be 745. So your weighted mean marks will be 74.5 is your CGPA, you may say. This reflects the importance of subjects with higher grades. So, calculation of grade point average in education, construction of index numbers, price index, cost of living index, analysis of portfolio returns in finance, determining average production cost with varying quantities, and economic analysis and business data analysis. For these purposes, your weighted arithmetic mean is used. And geometric mean, it is a measure of central tendency calculated as the nth root of the product of n observations. It is particularly useful for data involving rates of growth, ratios, and percentages. So your geometric mean is equal to the product of all the observations and square root of nth, square root of the product of all observations, where that n is the number of observations. So suppose say your annual growth rates of a company's revenues over 3 years are 10%, 20%, and 30%. So suppose say I will be converting this into growth factors like 1.10, 1.20, and 1.30. So my geometric mean of it is 1.10 into 1.20 into 1.30 and cube root of this product, and that is coming around 1.196. So average growth rate is 1.196 minus 1, that is 0.196, and geometric mean growth rate is 19.6. This is the use, or this is how we can calculate our geometric. So advantage, it is suitable for growth rates and percentages, less affected by extreme values as because we are considering products, and just because we are considering the product and making a square root of it. So if one of the value is very high or one is very low, then also it is less affected. It is useful for financial and economic analysis, and it represents compound growth accurately. But the disadvantage is that it is very difficult to calculate and understand. And if your data is very huge, then the calculation will be very cumbersome. It cannot be computed if any of the value is 0 or negative. So it is not suitable for simple data sets without growth rates. So it requires logarithmic calculations for large data sets. Okay, and which is not that easy for anyone, any layman or anyone who will be doing simple business. So uses of your geometric mean, it measures the growth rates in finance and economics, calculating compound interest and investment returns, studying your population growth, used in index numbers and economic indicators, measuring average percentage change. And it is basically the best measure of average when dealing with growth rates, investment returns, and percentage changes over time. So, whenever you are calculating the growth rate or GDP of your country, this particular average will be of useful. So, one more is your harmonic mean. By harmonic mean is a measure of central tendency used for averaging rates, ratios, and speeds, especially when same quantity, such as equal distance or equal units. Suppose say you are calculating the average speed of a vehicle. In that case, you will be testing that particular vehicle in a same distance. So in that case, your harmonic mean is useful. It is the reciprocal of arithmetic mean of reciprocals of observation. So harmonic mean is equal to n upon summation of 1 upon x, where x is the individual observation and n is the number of observations. So Example maybe, suppose a vehicle travels 60 kilometers at 40 kilometers per hour and 60 kilometers at 60 kilometers per hour. Find the average speed. Suppose a vehicle is traveling 60 kilometers at 40 kilometers per hour speed and 60 kilometers at 60 kilometers per hour speed. Okay, what will be your average? What will be the average speed of that particular vehicle? So distance is the same, that is 60 kilometers. So 60 kilometers, it is covering 40 kilometers per hour, and one more is 60 kilometers. In 60 kilometers per hour is the speed. So what will be the average speed? In that case, it will be 2, as because we are having two observations, 40 kilometers per hour and 60 kilometers per hour, divided by 1 by 40 plus 1 by 60. That is equal to 240 by 5 and is equal to 48. Okay. So what is the advantage? It is suitable for averaging rates and ratios, uses all observations in the data set, provides accurate results when time, distance, quantity, everything is constant. And again, over here also, as because we are calculating, or the formula is such that it is 1 upon means the reciprocal, or you may say the proportion we are taking, so it is less influenced by large extreme values. But the disadvantage is it is difficult to compute and understand compared to your arithmetic mean. It is also, as in case of your geometric mean, we cannot be in a position to calculate if any of the observation is 0. Over here also, harmonic mean cannot be calculated if any observation is 0. It is not suitable for general data analysis and very rarely used in basic statistical analysis. So your harmonic mean is used for calculating average speed over equal distances, averaging rates and ratios, financial analysis such as price earning ratios, business efficiency studies, and it is most appropriate average when dealing with rates, particularly when the quantity involved remains constant. So the next is your median. The median is the middle value of a data set. So when the observations are arranged in ascending or descending order. So this is the prior requirement before calculating your median of the series, that all the observations need to be arranged in either ascending or descending order. So this median value divides your entire data set into two equal parts, such as 50% of the observations lie below it and 50% lie above it. So it is a positional measure of central tendency, like your quantiles. So the median is the middle value. So, and the steps to calculate the median is arrange the data in ascending or descending order, determine the total number of observations, then locate the middle position using the median formula. This is when n is odd, your median is equal to the value of n plus 1 by 2th observation. And when n is even, it is n by 2 plus n by 2 plus 1 by 2. That is, if you are having 5 observations, then exactly n is equal to 5, then it is 5 plus 1 by 2, that is third value in the series. So just observe that we are having 5 numbers and all of them are arranged in ascending order 12, 15, 18, 20, 25. And our median value is just a middle one, and it is very much visible as because we are having 5 only, it is 18. So as because we are having 2 values above it and 2 values below it. But while calculating, we may calculate like 5 is the number, n is equal to 5. So n plus 1 by 2, that is 5 plus 1 by 2 is 3. So third value in the series is median, that is 18 here. So next, suppose say I am having an even number of observations, say 6 values, 10, 12, 15, 18, 20 and 25. So n is equal to 6. In this case, it is n by 2, that is 6 by 2 is third, plus n plus 1 by 2, that is 6 plus 7 by 2. Sorry, 6 by 2, 3 plus 1, that is 3 plus 1 is 4. Okay. The third plus fourth by 2, that is 15 plus 18 by 2, that is 16.5 is my median. Okay. So the median is especially useful when data contain extreme values and are skewed. It is not influenced by outliers. Means if any of the observation is very high or if any of the observation is very low, the median value doesn't change. So it is not affected by high observations, very high observation. If your series contains very high observations or very low values of observation, in that case, your median never have any impact as because it is a positional value. So if it is grouped data, then when the data are arranged in class intervals with frequencies, we call that as group data. So the median is calculated using the group data median formula. The median, as we know, it divides our entire distribution into two equal parts, where 50% of our observations will be lying below the median and 50% will be lying above the median. So median is equal to, in case of grouped data, our formula will be L plus n by 2 minus F by F into H, where L is the lower boundary of the median class, N is equal to the total frequency, that is total number of observations that you are taking into consideration, and CF represents the cumulative frequency before the class of your median class, and F is the frequency of the median class, and H is the class width. Okay. So suppose say my observations are like this. In this case, we are having, suppose say 3, 5, 7, 4, 1. So for calculation of your median, in case of your group data, we have to have one more column, that is cumulative frequency. And yesterday we were studying how can we calculate, that is 3, and the cumulative frequency of 10, 20 will be 3 plus 5 is 8, and it is 8 plus 7 is 15, 15 plus 4 is 19, and 19 plus 1 is 20. This is our cumulative frequency, and this we are having the maximum number of observations is your this. So you may say this is your median class 2030. Okay. So basing on that, we will be, that is maximum number of observations, that means the maximum frequency is of this class. That is, we are having the number of observations above it and below will be equal. So calculate the total frequency, n is equal to 20 and our n by 2 is 10. The cumulative frequency, just that is over here it is n by 2 is 10. So when taking our cumulative frequency is 15. Okay, so just greater than 10. Over here we are having just greater than is 15. So this is our median class. Okay, so the median class is 20, 30. So our values in our formula, L will be equal to the lower limit of the median class interval, 20. CF is the cumulative frequency of your median class. That is median class before that. That is 8. And frequency of the median class is 7, and the difference between the upper limit and lower class limit is 10. So by applying the formula, our median will be 22.86. So this value represents the central point of the grouped frequency distribution. So while calculating, so this may be a graphical representation. Your median will be equal to L plus N2 minus CF by H. So where your N by 2, that is N2, it is written N by 2 minus CF by F. So N by 2 is, so 20 plus 10 minus 8 by 7 into 10. So your L is equal to 20, the lower limit of the median class interval. Cumulative frequency will be equal to of the class preceding your median class, that is 8, and the frequency of your median class is 7, and your class width is 10. Next is the mode, is the value that occurs most frequently in your data set. It represents the most common or typical observation. Mode is especially useful for categorical data and market analysis. So if it is ungrouped data, then your mode is the highest frequency. Okay, so if it is value is 12, 15, 18, 20 and 22, and your 15 is occurring most times in your series, so it is your mode. 15 occurs most frequently. So if it is grouped data, that means your data is in class intervals or frequency distribution, then the mode is calculated as L is equal to F1 minus F0 by 2F1 minus F0 minus F2 into H. So your L is the lower limit of the modal class, F1 is the frequency of the modal class, and F0 is the frequency of the class preceding the modal class, and F2 is the frequency of the class succeeding the modal class, and H is the class width. Okay, sure. The calculation goes like this. Suppose say this is my series. Okay, over here my modal class is this, as because it is most frequently occurring values, the frequency is maximum of that specific class, that is 20, 30. So this is my modal class. So my L is equal to 20, lower limit of the modal class. F1 is equal to 10, that is the frequency of the modal class, and F0 is the frequency of the class preceding the modal class, that is 6, and F2 is the frequency of that specific class succeeding the modal class, that is 8, and interval between the two is 10. So our mode will be 20 plus 10 is F1 minus F0, 10 minus 6 divided by 2 into F1, 10 minus F0, 6 minus F2 is 8 and into class, you say width of the class interval. So that is mode is equal to 20 into 4 by 6 into 10, and that is equal to 26 plus 6, 7. A small, you may say graphical or you may say tabular representation is like this. This is one more series really, and everything marked in colors for your better understanding. Let us have a look of it. Okay, so moving further, advantages is it is simple to understand and look it, not affected by extreme values. It is suitable for qualitative and categorical data. It is useful in case of your market research. It, and disadvantages, it may not exist or may have multiple values. In that case, it is very difficult to make any analysis based on your mood. It is not based on all observations. It is being based on a specific set between three classes only. And it is not suitable for further mathematical treatments. That means, as in case of our arithmetic mean, we were making that difference between the sum, you may say x minus x bar summation is equal to 0. That sort of mathematical treatments, or adding anything to your observation or subtracting anything from your observations, or multiplying your observations with a specific constant and dividing. In that case, the changes in your mode cannot be that easily visualized. So it is less stable compared to mean. It is basically used in case of most popular products or brands. It is determining the most common size. It is being used for determining the most common size in clothing industry, studying consumer preferences, market demand analysis. And key idea is that mode indicates most frequently occurring value, making it useful for understanding dominant trends in data. Next is your quantiles. It is a basic statistical measure which divides your ordered data set. This also requires, as in case of your median, your quantiles to require that your data set should be ordered. By ordered, I mean it should be arranged in either ascending or descending order. So into equal parts, helping us to understand the position of observations within the distribution. And these are called as your positional measures because they indicate the location of a value relative to the entire data set. So we are having three sort of quantiles. One is quartiles, which will be dividing your entire data set into 4 equal parts, and each part contains 25% of your data set. And deciles, it will be dividing your entire data set into 10 equal parts, and each part will be containing 10% of the data set. And similar is the case of percentiles. It will be dividing your entire data set into 100 equal parts, and each part contains 1% of the data set. Okay, the Q, you may say Q1 is the first quartile, 25% of the data lie below this value. Q2 is the second quartile, which will be coinciding with your median. So 50% of the data lie below this value. And Q3 is the third quartile, that is 75% of the data lie below this value and 25% above this value. So formula for quartiles in case of your arm grouped data will be Qk is equal to k into n plus 1 by 4, wherein by Qk I mean k is equal to 1 or 2 or 3, and n represents the number of observations. So if my data set is like this, I have ordered this data set like 5, 8, 10, 12, 15, 18, 20 and 22. That is in a specific order in ascending order. And the number of observations that I have taken is 8. So the position of my first quartile will be 8 plus 1 by 4, that is equal to 2.25. So my quartile 1 lies between second and third observation, that is 8 and 10. So 8.0.25 into 10 minus 8, that is equal to 8.5 is my first quartile. The similar is the case. In case of second quartile is n plus 1 by 2, that is 4.5. That means it will be lying between 12 and 15. That is fourth and fifth observation in my data set. So it will be Q2 is equal to 12 and 15, so it will be 13.5. And third quartile, going in a similar fashion, it will be between 18 and 20, that is sixth and seventh observation, and it will be 19.5. So if my data will be is grouped data according to my frequency is arranged in class intervals and in a grouped frequency distribution, then my formula is like this, that is Qk is equal to L into K n by 4 minus Cf by 4 into H, wherein Qk represents the kth quartile, K may be 1 or 2 or 3, and L is the lower boundary of the quartile class, N is the total frequency, and Cf represents the cumulative frequency of the class preceding the quartile class, and F represents the frequency of the quartile class, and H is the what class, you may say class width or regular. Okay.